Hello everyone, I hope you are enjoying the Level Up series. In this series, I try to take one or two questions and go very deep into the concept. And if you are a physics lover, you will definitely love it. So today again, I have a very interesting question which says, what is the maximum angle to the horizontal at which a stone can be thrown and always be moving away from the observer? Now to know this question or to understand this question, please pause this video and try to attempt it on your own. And I know you will be tempted to solve it using calculus, but there is an interesting method as well. So I'll be talking about that. But before I talk about that interesting method, let me take you through a quadratic equation application in physics, which will be involved and utilized in this particular question. So you must have seen quadratic equation multiple times in physics. So quadratic equation, for example, the vertical motion. You know that in vertical motion, the quadratic equation, it can be written down as ut plus half at square, where a is termed as minus g if we take the upward direction as positive, and therefore the equation will become equal to ut minus half gt square. Okay, where u is the initial velocity and y is the position of the particle along the vertical direction. So now if I rearrange this and rewrite this whole thing, it can be written down as half g t square minus u into t plus y is equal to 0. Now clearly this is a quadratic equation in t, which means it will have two roots of t such that sum of roots t1 plus t2, which we have already studied in quadratic equation, is t1 plus t2 is minus b by a. Okay, and in this case minus b by a will become u upon half g, and therefore by rearranging it will be equal to 2u by g. Oh, you have seen this, right? So 2u by g you have seen earlier, and it was total time of flight in a vertical motion. So it clearly says that the two roots t1 and t2, their sum is equal to the total time of flight, and therefore I can say t is equal to t1 plus t2, which is equal to 2u by g. And what does this mean in this quadratic equation is when you throw a particle upwards. Okay, so let me throw this particle upwards with a velocity u, and when it is moving up and it is coming down at any position y. So let me just take any position y. I will take a position y, and at this position, when the particle is moving upwards, okay, when the particle is moving upwards, it will take some time t yahan se, so it will take some time t1 from here to here, and t2 from here to here again when it comes back to this particular position. So t2 is the time which is from here starting to again when it reaches the y position, and therefore t1 plus t2 will be equal to 2u by g. So this is how roots are defined at the maximum position. So if y is equal to maximum height, it will t1 will become equal to t2, and therefore you can clearly say that t1 plus t2 or t1 is equal to t2 at maximum height, and at that time it will be equal to u upon g. Okay, so at maximum height, so these are the few concepts which can be applied. Another application of quadratic equation, I hope you have understood it. And similarly, you can also see sometimes very interesting fact comes out of it, that t1 into t2 will be equal to, t1 into t2 is the sum of roots product of roots, and it can be written down as c by a, and it will be equal to y upon half into g, and therefore it will be 2y by g. And using t1 plus t2 and t1 t2, you can calculate t2 minus t1 mod, because whichever is greater I will subtract from it, and you can find this time, the difference between when it is moving up and it comes back to the same position. You can find the time difference between that, and you can calculate using t1 plus t2 and t1 t2, And this is your homework. Please write down in the comment box how did you solve it. Another application of quadratic equation can be in the use of projectile motion. So you must have studied projectile motion, and in projectile motion you write down the range or the equation of the path as y is equal to x tan theta minus gx square upon 2u square cos square theta. This is how you write down the equation of the trajectory or equation of the path of the projectile motion. Now here you can clearly see this is a quadratic equation, and this is a quadratic equation, two variables. So let us first rearrange this and write down the equation. G upon 2u square cos square theta x square minus tan theta x plus y is equal to 0. So one way of writing this quadratic equation is in this format, wherein you can see that if theta and u are known, so you can write down this quadratic equation in terms of x. Okay, so clearly when theta is known, you can write down this quadratic equation in x in this particular format, and you can clearly find out sum of roots or product of roots, and that is your homework. You can do it, but I was just trying to say that how it is applied in quadratic equation is applied in physics as well. The another format which is sometimes extremely critical and important is when y and x is given to you or known to you, and in that case what you do is, if I want to rearrange this, I can write down this as y is equal to x tan theta minus gx square upon 2u square, and cos square can be written down as 1 plus tan square theta. And therefore you can see when y and x are given to you, which means, let's say if a particle passes through certain point, in that case y and x is known to you, and the equation becomes a quadratic in form of variable theta, and you can rearrange it and write down as gx square upon 2u square. I can say it will be equal to tan square theta minus x tan theta, and then I will have y plus gx square plus 2u square. So this is a quadratic equation in this format, and you can solve it whenever x and y are given to you. So interesting thing, and therefore quadratic has a lot of application in physics, especially in kinematics, especially in motion in 1D and 2D. You can apply it multiple times, and lot of difficult questions can be solved using quadratic. So I hope you found this concept interesting. And now let's move back to our original problem. Okay, the original problem said that find the maximum angle to the horizontal at which a stone can be thrown and always be moving away from the observer. Okay, in this question, let us take few cases. Now, if I take a vertical motion case, what happens there? If I take a vertical motion case, a particle moves up, so it is moving away from the observer. So if you are standing or sitting at the origin, the particle is moving. When it is moving up, it is moving away from you, and when it is actually coming down, the distance between you, which is observer, and the particle is reducing, and therefore it is not always moving away from the observer. So let's increase the angle a little bit. So when I increase this angle a little bit, here the particle clearly is moving up, away, and here it might seem it is moving away, but now the distance you can see here, it is lesser than this particular distance, and therefore it is coming closer to you. So clearly it says that there are cases wherein particle will be coming closer to you. So how to understand and how to approach this problem? One way is very simple. You find x, you find y, you actually find in position by actually adding x square plus y square, which is a variable in time, and then differentiate it with respect to time, and that is a conventional method. Now, can you think of a very interesting method here? An interesting method can be, let's look at the position vector. Okay, let's look at the position vector. Let's say this is the position vector, and let's look at the velocity vector. Okay, so here if you look, when it was away, moving away, you look at the velocity vector. Velocity vector is this. Now here velocity vector is this, and clearly you can see when it is actually decreasing, the angle between velocity vector and the position vector, when it is decreasing, the angle between the velocity vector and the position vector becomes acute. Okay, the angle is acute. And clearly if it is increasing, if, let me draw another case, and let me draw a case like this. Okay, let me draw a case like this. Here in this case, you clearly see, if this is the position vector, the velocity vector is making an angle which is obtuse. Okay, and obviously here it is making an obtuse angle, and you can see the distance is increasing away, and it is away from you. So now if I use this concept, the problem will become very, very easy. So the concept says that if r, which is the position vector, and if v, which is the velocity vector at any point of time, if the dot product or scalar product of r and v is greater than 0, which means the angle is obtuse between r and v, then in that case the distance or the r vector will keep on increasing. It will never decrease. And that also we studied somewhere in acceleration and velocity, which I will discuss later on in some other concept. But here you can clearly see, if two vectors dot product is greater than 0, which clearly indicates that this vector r is always increasing and it is not decreasing. And now I can solve this question in an easy peasy lemon squeezy way. R vector can be written down as u cos theta. You can say x is equal to u into t. So u x t I cap, this is the position vector, plus u sine theta into t minus half gt square j cap. This is the position vector, dot the velocity vector, which is equal to u cos theta I cap plus u sine theta minus gt j cap, the dot product of these two, and this will be greater than 0. So clearly what we have is, I can solve this. So it will be I dot I. So I dot I is 1, u square cos square theta will be the first term into t, and then this is multiplied, I dot j is 0, and therefore j dot j will become u square sine square theta into t minus half gt square u sine theta, and then we will have minus gt square u sine theta, and then we will have plus half g square t cube, and this is greater than 0. Okay, so now let's actually go here and solve this. What we will have is, this is u square into t minus, if you look at this, gt square, so minus 3 by 2 gt square, we have u gt square u sine theta, and plus half g square t cube is greater than 0. So now t, this square gets cancelled, and what we will have, what we have to find. So this is a quadratic equation. You can clearly, quadratic expression rather, because equation is when it is equal to 0. It will be equal to half g square t square, and then we will have minus 3 by 2 g u sine theta into t plus u square is greater than 0. And if a quadratic expression is greater than 0, if a quadratic expression is greater than 0, then the roots are not real. Okay, and this is a very important concept, that if quadratic equation is quadratic expression is greater than 0, which means the roots are not real. Okay, so let me just rearrange it and let me solve it again. So here, if I say that roots are not real, what does it mean? It means, let me just solve it. Discriminant is less than 0. And what is the discriminant? Discriminant is, and I've used the quadratic equation funda, which I just told you, right? So what will happen is 9 by 4 b square, which is 9 by 4 g square u square sine square theta. Now this minus 4 u square into half g square is less than 0. So u square, g square, u square, g square, this gets cancelled, and therefore sine square theta is less than 8 by 9, because 4, this gets cancelled, 2, 4 into 2, 8 by 9, and clearly I will get sine theta is less than under root of 8 by 9. Or I can say this is equal to, I can solve it or I can leave it. It will be 2 root 2 by 3. Okay, so this is how, or 2 by root 3. I can easily put it like this. Oh, sorry, 2 root 2. My bad. So it is simply 2. I can leave it like this. Okay, so sine theta is less than 8 by 9. So clearly you can see and appreciate that a difficult problem can be solved in a much easier way if you follow the concepts deeply. But physics is so very interesting, and it has so many angles to it. You can solve it in multiple ways, the way you visualize. And of course, the conventional method is always there to help you out. But I always will challenge all of you, if you are preparing for Olympiad or JEE Advanced, to think it in a very different way and try to open up your mind to solving physics in a very unique way. Okay, I hope you have liked this session. Please give me a thumbs up. Please share it with as many friends as possible, and write down in your comment how did you find this video. If you like it, I will keep making such videos in the future as well. And let's learn physics with me, Anand Prakash, co-founder of Vedantu, in a very interesting and in a very fun way. See you for the next question. Okay, bye-bye, take care. And in the meanwhile, you can join the Telegram channel, V_WAP. Me and Pulki sir keep sharing a lot of content there. Thank you.